Hello, my genius students. How are you doing today? Hope you're doing well. Welcome once again to Dr. Saurabh's classes. We are back again with another set of great and beautiful videos on group theory. In the previous video, we spoke about cyclic group, and then I gave you an examples of cyclic groups, and I also showed you how in integers -1 and 1 are the generators, how you can generate the set of integers with just one and -1, how 1 plus 1 plus 1 plus 1 equals to 4 is one of the integers, right, belongs to Z. So like that it was. Today we are going to talk about some examples on non-cyclic groups. Okay, very important part, students. Cyclic group was important, non-cyclic group is equally important. All right, so let's begin without wasting much time. We are on chit chat. Okay, so let's begin with the first one. The first one is Q plus, that means set of or group of rational numbers. This is a group of rational numbers, not set. Is G because it's Q plus with binary operator. So group of rational numbers with plus as binary operator. Okay, so the group of rational numbers with plus, let's write that plus properly, with plus as binary operator is a non-cyclic group. So this is a non-cyclic group. This is a non-cyclic group. Right on till there. This is a non-cyclic. Why non-cyclic group? Because we cannot find a generator to generate all the elements of this group. Moving on to the next one is the group of GR of real numbers with addition as binary operator, OPP. Okay, with addition as binary operator. This also is a non-cyclic group, isn't it? Why? Because you will not find any generator that will generate all real numbers. Let's say if I say, let's show you root 3. What will generate root 3? Root 3 is a real number, right? It is an irrational, but still it's a real number. All irrational numbers are real numbers. So what can you say about that? What will generate root 3? You cannot get a generator, okay, that would generate root 3. Alright, moving on to the next one, part 3. It says that the C plus means group of complex numbers with addition as binary operator. So the group of complex numbers with addition as binary operator is not a cyclic group. Okay, this itself is again not a cyclic group. It's not a cyclic group. Now moving on to our next one. What is the next one? Q star. Now there was during these videos when I had said that Q star is of, Q star, R star, any star is a prime, is primes, but it's actually not that. It is something else. Okay, usually we denote those stars as a prime, but let me just rectify that part for you. Okay, if anywhere I have said Q star or something is prime, then I would like you to rectify that. It will be a group of non-zero rational numbers. This is a group of non-zero rationals, non-zero rationals with multiplication as the binary OPP. Oh, you can see the dot here. Here is the dot. Okay. So multiplication as the binary operator. Okay, let's put the dot here. Yeah, here also I can't see the dot, so I just want to put it on my own. Okay, the person who has made this presentation for you needed to put some other dot, but anyways, now it doesn't matter. Okay, we need to understand that Q star is a group of non-zero rationals. Okay, anyway, did I say prime? Please get rid of that. It is a non-zero rationals. So the non-zero rational numbers with multiplication as the binary operator is not a cyclic group. All right, moving on to the next one. R, the group of R star, that is a group of non-zero reals, with multiplication as binary operator. This again is not a cyclic group. All right, this again is not a cyclic group. So you will not find a generator. Okay, you will not find a generator which will generate each and every element over here. So that's not possible. All right, let's move on to the next one, the complex. So group of non-zero complex, with multiplication as binary operator. Binary operator is written on top, so I showed you with an arrow. Okay, so this again is not a cyclic group. All right, now I am not going to show you mathematical examples on this because they are just saying that these groups are not cyclic. If they were cyclic, then there would be a reason to show you a mathematical example, but since it's not cyclic, so there is no need of showing you a mathematical example. Just understanding that these groups are not cyclic, okay, is enough for you. All right, you will not require a mathematical example for this, so there is no need of any mathematical example here. Okay, there is no need. So if they ask you can you list a few non-cyclic groups, if they ask you a question like that in the exam, so what are you going to list? You're going to write Q plus. Okay, then you're going to write at the side the group of all rational numbers with plus as a binary operator is not a cyclic group. And they ask you another one, then you say C plus. They ask you another one, then you say R star dot. Okay, so like that you can go ahead and just give an example, as a common normal example, that okay, this is not a cyclic group, okay, that is not a cyclic group, okay, that one is not a cyclic group. Okay, so you don't have to show any mathematical example. Okay, moving on to the next one, that is the seventh one. The seventh one is given as G is 1001 identity, then 100 minus 1 has changed to minus 1, then minus 1001. Now if you notice, in the first one there is no negative, in the second one this part has got a negative, in the third one this one has got a negative. Now the next option is both are negatives. This is an abelian group, no doubt about that. Okay, the commutative property will be satisfied, but under multiplication, but it is not cyclic. That means we will not get a generator. Non-cyclic means no generator. We will not get a generator, so this group is a non-cyclic group. But the group is abelian. Okay, you can multiply and check. that the group will be abelian. There are 4 elements already given to you. You can take any 2, multiply them, and again reverse it and multiply. Like you can take this as A, this one as A matrix, and this one as your B matrix. Then you can do A dot B, okay, and get an answer. Alright, then you can do B dot A and get again the answer. This is answer 1, this is answer 2, suppose. So A1 will be equal to A2. Answer 1 will be equal to answer 2. Alright, so did you understand this part, students? It is just different from the cyclic group. The cyclic groups will have a generator, the non-cyclic groups will not have a generator. So we will not be able to find a generator for a non-cyclic group. So students, that's it for this part. Okay, I don't want to confuse you too much with this, because there is a lot of information that you are gathering into your head and a lot of notes you are making, but don't worry, it's worth it. Okay, go ahead and make these notes, go ahead and take the examples, whatever I have told, whatever I am giving to you. Make notes, study hard, and do well in your exam. And any type of help you need, you can come to Sort of Sir's classes, you can join our classes, watch our videos, do whatever you want. Okay, we provide online classes, offline classes, anything. Okay, so keep taking as much help as possible from Dr. Sort of Sir's classes, because all the help that you will be needing will be always provided here at Sir Sort of classes. So thank you for watching, students. We will continue this in the next video. Bye bye.